Namaste Coders, I hope you are fine. So today's problem is a very important problem from DP, right? So today's problem is a very important problem from DP, and that's why I'm gonna cover this problem before solving today's problem of the day. So the today's problem of the day is shortest common subsequence. So this problem is completely based upon longest common subsequence, right? So I'm gonna explain it this problem to you first, then I will start with the today's problem of the day. So the problem is longest common subsequent. It is the most important problem from DP to dynamic DP, and this problem is also the part of LeetCode 75. Here you can see longest common subsequence. So I will add this video in that playlist also. So let's start with the problem. So the problem is we have given two strings, text1 and text2. Return the longest common subsequence. If there is no common subsequence, return 0. This problem is asked in an interview. So I am talking about my interview. This problem is also asked to me in an interview at our third round of DSA, right? So that is a very important problem. That's what I'm saying. So before starting the problem, I have something to you. So this problem is a part of LeetCode 75. This video is a part of LeetCode 75 series. So along with LeetCode 75, as I've said earlier, we have already started the series of LeetCode problem of the day. So I have committed to solve LeetCode problem of the day daily and upload the video. Sometimes I'm not able to upload a video due to some personal reasons, but still I always try to upload the daily LeetCode problem of the day. So yeah, both the link of the playlist are given in the description. Along with these playlists, I have also created a WhatsApp group for the coders, right? So we can use that group in a multiple ways. We can solve our doubts, we can discuss multiple algorithms, problems, we can also start some good projects. So we can connect with different coders along the world. So if you want, you can join that group using the link given in the description, right? So let's start with the problem. So as we have discussed, there are two strings, text1 and text2. We have to find the common subsequence, right? We have defined the longest common subsequence. So what is subsequence is? A subsequence is a string. Subsequence of a string is a new string generated from the original string, which some character can be none deleted without changing the relative order. Okay, so subsequence is, let's say we have given A, B, C, D. So subsequence can be A, C, E, right? Because we can choose any character in a relative order. We cannot choose A, C, B. This is not a subsequence because order got changed. We can choose A, B, C. A, B, C can be a subsequence. A, B, C, D, E is also a subsequence of this. So we can choose any character in a relative order. So that is a subsequence of a string. So we have to find longest common subsequence between the two strings given, right? So what is the longest common subsequence? We can take A, then we have to take C, and then we have to take E. So the AC is the answer. So AC is the subsequence of this ACE and this ABCDE. So the answer is 3 because we have to find the length of longest common subsequence, right? So in this ABC and ABC, answer is 3 because ABC is a subsequence of ABC, right? So let's discuss how to solve this problem. So details are, we have given two strings, we have to find the longest common subsequence. If there is no longest, right? So let's start with the example, right? So we have given, let's say, two strings. Okay, first is A, B, C, C, D and E. Second is A, C, E. So the what is longest common subsequence? So we can start from initial strings, and we can check that A and A is common. So we will make L, and L is currently at 0. Now there is no B present. C, yeah, So we can choose C and then E. So the AC is the longest common subsequence. Let's talk about the different example. This is a very common example. Let's take this example, right? This is uh, E Z. This seems simple, but there is a one complex part which we need to address, right? P, K, and R. Okay, and second is U, B, M, R, A, P, and G. Now think that let's start with the E, and we will find E here. There is no E. Okay, so we'll take Z, and if there is a Z, there is no Z, then we will take U. Okay, let's take U here. So our length is currently 1. Okay, now we are at P. Okay, so should we take P? Huh? So yeah, we can take P, and there is R. So okay, now let's say this is the first string. Okay, consider my words. So as we take P, we can take only this range, right? Because there is, this is G, and we can take only this range, because if we take this R, the order will get changed, and that will not become the subsequence, right? So we can take, if we choose this P, we have to take only this range. Now there is no R, no K, and no J. So length, according to this, our length is 2. So, but is this really the longest common subsequence? No. So if we ignore this P, so our length will remain 1, because U and U are common, right? Then we will take this R and this A. So U R A is really bigger subsequence than U and P, right? So the longest common subsequence is 3, not 2, right? So that is the key point here. So how to address this? What can we do? So let's solve this problem. Let's discuss a native approach. So as you are if you are a regular viewer of my videos, you will be aware that I will solve videos in 3 steps. First we will discuss the details, so which I have already done. Then we will solve the problem in a native approach. Then we will try to optimize that native approach using some data structure or algorithm. So in this video we will optimize this problem using 2D DP, but first we will discuss the native approach, right? So that is also a similar structure of interviews, so we will gonna have some practice of interviews also. Okay, so how to solve this problem in a native approach? So let's take the similar example. U P K R but A. Okay, and second is U B M, sorry for my handwriting guys, A P and G. Okay, so what can we do? In a native approach, first thing we can do is we will make all the subsequence, right? So so let's say this is of length n and this is of length m, right? So for making all the subsequence, we will have to make 2 to the power n minus 1 to the power n minus 1 plus 2 to the power m minus 1. So these are the total subsequences which we can make, and then we will have to compare these subsequences with these subsequences, and if there is a common subsequence, means the similar subsequence, we have to find the length. Then we have to update the max length, right? So what is the time complexity, guys? What is the time complexity? This is a huge time complexity for making subsequences also only, but still 2 to the power n plus 2 to the power m. So this is the time complexity for making subsequences. Then for comparing, we have to compare these subsequences with these subsequences, right? Okay, so this will be 2 to the power n plus m. So the overall time complexity will be this, because this is the bigger part, right? So this is a huge time complexity. It's because n plus m can go to 2000, right? 2000 to 2 to the power 2000 is like a hilarious time complexity, but still, this is a native approach, so we have to think about a native approach first. So how can we optimize this? We can use 2D DP, right? So what can we do? So let's say E Z U P K R A and U B M R A G A P G. Okay, so at every point, right? At every point, first we have to check. Let's say we are at I equals to 0 and j equals to 0. At every point we have to check that if I equals to j, if text1 I equals to text2 j, if that is not the case, either we will update I, either we will update j. Okay, and then we have to check. So let's say I is at u and j is at j, right? J is also at u. So we will have to check that if text I is equals to if text1 I is equals to text2 j. So yeah, this is the case. So then we will have to take two cases, like two decisions. Either we will choose this, or we will ignore this similarity. So how to choose this? So we can choose using dp I j, right, equals to, if we choose, that will become 1 this length, right? 1 plus dp I minus 1 or j minus 1 j minus 1. So this is the case if we have choose this, right? So we have used this length in the common subsequence, and we will go to the next dp, right? Next dp. So this is the bottom up approach, of course, right? Then if we have to ignore this, so what we can do, we can use either we can use dp of I minus 1 and dp of j, or either choose this or this comparison, either dp of I dp of j minus 1. So we will have three choices if we have a similar case, right? So whatever the maximum, we will choose that. So we have to choose the maximum out of these three, right? So that will become dp of I comma j. And if they are not similar, so dp of I comma j will become maximum of these two cases only. So we don't have this third case, right? If there is no common. So I hope you understand this, how to use dp in this problem. So let me explain it to you again. dp of I comma j is nothing but the length of longest common subsequence up to the ith part of text1 and jth part of text2, right? So we have used this condition. So if we are at this I, right, let's say we are at this point, what we can do, we can choose the length of longest common subsequence of the previous part, right? we can choose the length of longest common subsequence of previous part. Then we will see if these are common or not. If they are common, we will update the previous part plus one, or we have the choice that we have to take this or not, because we have seen that case, right, in which if we are gonna ignore the previous thing, if we're gonna ignore some character at the first place, that will get gonna be helpful, right? So yeah, this is the overall thing. Let's code this. So we have int I equals to so let's say int n is nothing but uh, text one dot size. So I am gonna code in C++. I can code in Java and Python also. If you want, you can ask the solution in Java or Python. Text 2 dot size int I equals to 0, int j equals to 0. We'll make dp vector int. This is the 2D dp of length n comma vector n comma 0. Okay, now while I is smaller than n, j equals to I, right? J can be start from I only. No, j can be start from 0. Why j is smaller than m. Okay, so there are two cases. First is if text 1 I equals to text, I am using bottom up approach, right? Text to j, if that is the case, we have to do something, else we have to do something. So what we need to do? Okay, so if first of all we can make this plus 1, right? Plus 1, because for I equals to 0, j equals to 0, right? The I minus 1 and j minus 1 will be is minus 1 minus 1 up. So that will got out of range for dp. So we'll use one indexed table for dp. Okay, so if text 1 equals to text 2, right? So what is dp of I plus 1 j plus 1? What is dp of I plus 1 j plus 1? It's nothing but maximum of three things. 1 plus dp of I minus I j comma maximum of dp of I j plus 1 comma dp of I plus 1 j, right? Else this is the similar thing we can do, but we have to remove this because we cannot check the length. And okay, now what we will do, we'll have to return dp of n m, right? So let's run this. Okay, sorry, what is this? Okay, not max, this is only one max. Or here we'll make j plus plus here and make I plus plus here, right? So let's I hope this will get submitted. Yeah, all the test cases getting passed. Let's submit this code. So yeah, this is getting past. So that's all guys in this problem of longest common subsequence. I hope you understand this problem well. If you want me to explain DP in depth, right? So I have used DP here, but I've not explained how DP is actually working. So if you want me to discuss that, you can ask me in the comment section. I can explain DP in a very depth, right? How's the actual working of DP, how to visualize DP, what is bottom up approach, what is top down approach, what is 1D DP, 2D DP, multi-dimensional DP, how to how to think of a solution in which we can use DP. So there are a lot of things about DP. DP is the most vibrant and most important algorithm of DSA. So if you want anything, if you want any video, you can ask me directly in the comment section, or else you can join that WhatsApp group and we can discuss multiple things there, right? So thank you for your time. That's all from my side in this video. Thank you. Have a nice day.